Example 2. Determine in polar and rectangular form the current flowing in an inductor of negligible resistance and inductance of 159.2 millihenry when it is connected to 250 volts and 50 hertz supply. Now interpret. Let me just the fact is that whenever you are given a question, try to understand that question, right? Know the parameters given and know the parameter you are looking for, meaning the unknown parameters. Then with that being done, after doing that, draw your circuit diagram. Draw what? Your circuit diagram. Now let's interpret that question. Given data, what are we giving from that question? Okay, from that question, let's read the question together. Determine in polar and rectangular form. So let's write it down. Meaning Z. Okay, what are we to determine in rectangular and polar form? All right. Now, from what we did previously, we said this is our representation in polar form. In rectangular form, Z is equals to what? A plus JB. And for rectangular form, Z is equals to R all into bracket cos theta plus J sin theta, which is equivalent to what? R at theta degree. Now, what are we asked to determine? Current, right? Meaning at the end, current I must be expressed in what? A plus JB, right? Similarly, this same current must be expressed in what? R at theta degree. I get what I'm saying? You are following that question. Question says that determine in rectangular and polar form the current flowing through an inductor, right? Continue your reading. In an inductor of negligible resistance and inductance of what? 159. All right. Now from here we are giving V to be 250 volts and F to be what? 50 hertz, right? Now from here, this is our diagram. This diagram, we want to determine this is the inductance. In some cases, you might have this. Sorry, this is the inductor, or you say coil. Do you agree with me? So meaning you might see inductor or coil, and this is your resistor. And from giving data, you have negligible resistor, right? Negligible resistor meaning 0 ohms. The value here is what? 0. Now you are giving your voltage source to be what? 250 volts. You are giving F to be 50 hertz. Now you want to calculate the current flowing through this inductor. Let's say I. Let's denote it as I. Are you getting me? We've interpreted that question. This is the diagram interpreting that question. We want to find the current. We want to find the current in rectangular form and polar form. The current flowing through this inductor. The current flowing through this inductor of negligible resistance, meaning 0, right? And we are given that this is the supply voltage and this is the frequency. Now, by formula, relate this to Ohm's law. This is what? V equals to what? IR. Call this equation 1. Now, in place of R, this is where you'll be implementing our theory aspect. You've done a lot of theory explanation on this, right? So this is where you'll be implementing it. Now, from Ohm's law, equation 1 can be written as what? V is equals to what? IZ. Do you agree with that? So call this equation 2. Now, what are we looking for? Question given. What are we calculating? What's my interest from equation 2? I. Now, make I the subject of the formula. I becomes what? V over Z. Call this equation 3. Meaning, I'm going to use equation 3 to get the current. By the time I know the current, I'm going to express the current in polar form and what? Cartesian form. So now, what are these unknown? The unknown is what? V. The unknowns here are what? V. But the value of V is given, right? To be what? 250. So V is not unknown. Z is what? Unknown. By formula, what's Z? Z, check this circuit. This circuit, is it RC circuit or RL circuit? RL circuit. This is RL series circuit. Now for RL series circuit, what's Z? What's the formula for Z? Z is equals to what? R plus SL JXL. Z is equals to R plus JXL. What's the R? 0, right? You already know the value of R to be 0. Now, how do you get XL? What's the formula for XL? 2 pi FL. 2 pi FL. Now, we already know 2. We know F, right? What's L? L is given from the question. 159.2. L from the question, we are given that L is equals to 159.2 millihenry, and that's what we are looking for. We want to know the current, the value of current flowing through this inductor. So right, L is what? 159.2 millihenry. Any question on that? Now let's substitute. XL becomes what? 2 pi. Substitute the value of your frequency, 50. Substitute the value of your L. That's what? 159.2 times 10 raised power what? Minus 3. You put this in your calculator. What's the answer? This is 50 ohms. Therefore, my Z is equals to what? 0 plus J50. My Z is equals to what? 0 plus J50. Now, I said, go back to the question. Determine the value of current flowing through this inductor, which is what? 159.2 millihenry. In what? Polar form and rectangular form. Now, you already know that to get this current, you are using equation 3. You are using what? Equation 3. Now, let me tell you something. This equation 3, your voltage, this voltage must be in, it is easier. Let me just say this. You already know that you are using equation 3. Now, it's your choice. Equation 3 must be in rectangular form or polar form. Equation 3 must be in what? Rectangular form or polar form. But up to this level, it's always easier if your equation 3 is in polar form. It's always easier if your equation 3 is in polar form. Okay, now this is it. From here, let's go back to complex number. Say in complex number, we have I equals to A plus JB over, okay, let me use numerical value. Let's say I is equals to 3 plus J4 divided by 2 plus J, right? Call this 1. Then 2, say I is equals to 3 at 40 degree divided by 2 at 20 degree. Call this 2. Now, how do you calculate the value of I in 1 and how do you calculate the value of I in 2? Which one is easier? From complex number, from what you know in complex number, which one is easier? Okay, you think one is easier, though both of them they are actually easier, right? But the thing is that for equation 1, I just need your answer. Just tell me how to get I using 1 and tell me how to get I using 2. Now, say you are in complex number class, you are giving this complex number, you are giving this complex algebra. Now, how do you get this I? How do you get this I? From 1 and 2. Say you want to get the value of I using 1 or 2. From 1, there's what we call conjugate. Conjugate of a complex number related to surd. Conjugate is the opposite sign. Say you are giving a surd number which is positive, the conjugate becomes what? Negative. Now, same idea. For 1 now, you want to solve I using 1. Your task is that check the denominator. What's the conjugate of the denominator? 2 minus j. 2 minus j. What it means that multiply the given question, both numerator and the denominator with the conjugate. Multiply what? The given question. Having identified the conjugate of the denominator, this given question, now multiply the conjugate of this denominator by the numerator and the denominator. So what it means is that from here, you said the conjugate is what? 2 minus j. Meaning solving I using equation 1, I becomes what? 3 plus j4, right? All divided by 2 plus j multiply by 2 minus j, multiply by 2 minus j. You simplify further, right? By the time you simplify further, you get the value of I. By the time you simplify further, you get the value of I, meaning doing your algebra, doing distribute, right? Now, say you want to use 2 to get I. Say you want to use 2 to get I. This is you'll be the one to tell me this, but let me just tell you the general form. Now, go back to polar form of complex number. So you have z is equals to r open bracket theta 1 all divided by m theta 2, and you want to get z. You want to get z here. The idea is that to get your z from what we have here, z becomes r divided by m all into bracket theta 1 minus theta 2. Now apply same idea to number 2. Tell me the value of I. I becomes what? 3 divided by 2 is what? In decimal 1.5, right? 3 divided by 2 at what? 40 degree minus 20 degree, and this is what? 1.5 at what? 20 degree, and this is the answer. Now back to my question. Using 1 and 2, which one is easier? 2. Exactly. Using 1 and 2 is easier, because by the time you use 1, you end up getting a rectangular form, and that rectangular form that you get, this what you've gotten from equation 2 is polar form. This polar form, by the time you convert it to rectangular form, you definitely get what you've gotten here. You get the logic now? You definitely get what you've gotten here, which is 1.5 at 20 degree. You definitely get it by the time you convert back. So what I'm saying is that up to this level, I want to implement equation 3. It is always though it doesn't mean anything, but for sake of calculation, I will recommend for you guys that up to equation 3, make your v to be what? Polar form. Make your v to be what? Polar form. Meaning express your v in polar form. Also express your z in polar form. It will make your calculation easier. It won't stress you. Though you might go the opposite way, you get it. But for me, I will advise, make up to this equation 3, make your v to be what? In polar form, and make your z to be what? Polar form. Because you've seen that yourself, you've concluded that yourself, that using 1 and 2 is what? Easier. Because at the end, if you recall, the question says that calculate your r in polar and what? Rectangular form. So up to this level, you've calculated the polar form. From here, just convert to rectangular form, then you are done. How do you convert? Yeah, you do that. You see that. So what this means that you must know your complex number very well. You must know your complex number. And this is just this AC circuit. If you go to parallel, the complex number you are using here, it's the same concept though, but it will be a bit it's just a step further. Let me put it that way, a step further. Though it's still the same concept you are applying. Alright, moving on. Any questions so far? You are up to this level. I'm expressing equation 3 to what? Polar form. Expressing equation 3 to polar form. Now the question is, my v that I already have, how do I express this v in polar form? And how do I express this z in polar form? Now, this z that we've gotten, I would have substituted into, it's not left to me, right? This z, I can use it directly in equation 3. Are you getting me? Why do you think I can use it directly in equation 3? Because it's already in rectangular form. And at the same time, I can convert to what? Polar form. But I said that always convert to what? Polar form. Now, it's very easier. Since you are converting equation 3 to polar form, it is meaning equation 3 is equivalent to this. You can write equation 3 as this. I equals to v then 0 degree all divided by r at theta. Now, what this means is that this equation 3 is equivalent to this. Now, from here, you observe that for v, it is not changing. I'm just having a 0. I'm just including the angle to be what? 0. Because by the time, this is already in polar form. This polar form, your answer, by the time you convert this polar form to rectangular form, you still get this value. You still get this same value of v. Any question? No question. Let me explain that better. Let's say from here, I said this equation 3 is equivalent to this. Now the question is, this v, why do I have my v as v then 0 degree? The idea is that, say you have 2. This is the, of course, this is your rectangular form. Let's say you have 2 plus 0j. This is your rectangular form. Okay, let's just say you have 2, right? This 2, this is your rectangular form, right? This rectangular form, equivalent to polar form, you can write it as what? 2 then 0 degree, because this is still the same thing as this. Are you getting me? This is still the same thing as this. So that's what I just did here. Therefore, this r then your sine theta degree. What it means is that you are going to use z to solve for r, and you are going to use z to solve for theta. Now come back to this place. What was your z that you calculated? 0 plus j50 ohms. Meaning, using 0 plus j50 ohms, you get the value of r and you get the value of theta. By the time you get the value of r and theta, substitute. That is, v is already in polar form and z is already in polar form. Now let's solve. Using z, let's solve for r and theta. Because given that z is equals to a plus jb, and given that z is equals to r into bracket cos theta plus j sin theta, right? Now from here, this is your rectangular form, right? And this is your polar form. How do we have this rectangular form to polar form? There's a derivation for it, but I won't be doing that here. You can watch complex number videos. You get? Now from here, just now by formula, r is equals to the square root of b square plus a square. This is how you get your r, and this r is called the modulus of z. Is either in some question you won't see r directly. The question will just say find this. What this means is what? R. It is telling you that find the modulus of z. By formula, this is the modulus of z, and this is how we get the r in polar form, which is equation 2. Now, how do you get your theta? Meaning, theta is called the argument of z. Theta meaning argument of z. By formula, your theta is equals to tan inverse of b over a. There's a way we derive all this, but I won't be doing that here. We are in applied electricity class. You get? So now, meaning, come back to your question here. This is your z. Identify. You want to get r. Call this formula 3. Call this 4. This is your z. You want to get 3 and you want to get 4. Right? Now, identify. What's a? What's b? A is what? 0. B is what? 50. 50, right? Now, let's get r. R implies what? 0. Okay. 50 square plus what? 0 square. And this is still what? 50. Do you agree with me? Now let's get theta. Theta becomes what? Tan inverse of what? Identify. What's your b? 50. You are going to do a strange thing from here. Just input this in your calculator. Tell me the answer. Tan inverse of 50 over 0 is what? Tan inverse of 50 over 0. That's what? Not to waste our time. Now from here, what you are going to do is that, mathematically, 50 over 0 is what? Undefined. Or you say math error. But in this case, it is hypothetical, right? It is hypothetical, but we can back it up, right? Now from here, 50 over 0, it means you can still write this as saying 50 over 0 tends to infinity. 50 over 0 tends to what? Infinity. Meaning that what you have here, well, you prove it, meaning that theta, which is equals to tan inverse of 50 over 0, meaning 50 over 0 tends to infinity. That is, theta is equals to tan inverse of what? Infinity. Now, check that your calculator. Do you have infinity sign here? Do you? It's not here. Now, how do we get this answer? The answer is 90. How is it 90? Now, what's the idea behind infinity? A larger number. Right? A larger number. Now, press down your calculator. Choose a larger number. Choose a larger number. Don't tell yourself the larger number. Just press that larger number. Press tan inverse of that your larger number that you've chosen. Your answer will be 90. Choose a larger number. When I say larger number, choose 20,000. Choose 50,000. Don't use that phone. Use Casio. Choose a larger number. When I say larger, choose 50,000. Choose 15 digits. Everything is 90. Choose a lot of larger number, choose it. What do you have? 90. So meaning that theta here is what? 90 degree. So what this means is that you encounter this as you start solving more problems, more questions. So whenever you have something like this, tan inverse of 50/0, meaning 50/0 tends to what? Infinity. We are saying that it tends to infinity because mathematically we don't have it. I get me? When we say tends, probably it is closer. We can relate it to it. Mathematically, say you press this in your calculator, you won't have the answer to it, right? Hope you are getting me. But in this case, you say that 50/0 tends towards infinity, and by infinity meaning larger number. By larger number, 15,000, 20,000. Any larger number that you press in your calculator, saying that tan inverse of that larger number, you get 90. If you are not getting 90, you get 89.99, right? And approximately 89.99 is what? Still 90. So in essence, what it means is that whenever you have something like this, your answer is what? 90. No stress. Now, back to this place, I already know my R and I already know my what? Theta. Right? Any question? Any question? Please give me the energy. Any question? No question. Now, from here, this is my Z. This is my Z in what? Rectangular form. And I need my Z in polar form. What's the value of R that I got? 50. What's the value of theta that I got? So substitute, meaning Z in polar form can be written as what? 50 at what? 90 degree. Yeah, that's it. Any question? Now substitute. Equation 3, which is I, is equals to what? V over Z implies V at 0 degree over R at what? Theta degree. Now substitute your values. Substitute the value of R and theta. Now our unknowns here are what? You already know V. V is 250. R is 50 and theta is 90. Now substitute, meaning that I is equals to 250 0 degree. What's R? 50 at what? 90 degree. Therefore my I is what? 5 go here 1, 5 go here 5, right? Meaning 5 0 minus 90. What I explained before previously, that's what we are applying. That is I is equals to 5 negative 90 degree. We've answered question 1. Question 1 says that calculate the current flowing through 1.592 millihenry in polar form and what? Rectangular form. So this is question 1. This is the polar form. Now to rectangular form, what do you do? To rectangular form, what are you going to do?
5 cos.
That becomes what? 5 cos minus 90 minus 90. 5 cos minus 90 plus j sine minus 90. Now input this in your calculator. What's the answer?
5
times 5. Now input this in your calculator. What's the answer? When you input this in your calculator, you have 0 minus j5. So this is your answer. Therefore I is equals to 5 at negative 90 degree or what? Minus j5. This is in polar form. Why this is in what? This is in polar form. Why this is in what? Rectangular form. So you answer that question. So we join your diagram. Substituting the value of the I that I've calculated. This is V. What is V? 250 volt. F is what? Please let me check. What's F? 50 hertz. This is negligible resistor, right? L is what? 1.592 millihenry. Now, what will be the value of current that you are going to substitute? Meaning that from the given question, the current flowing through this inductor, that is 1.592 milliampere, is what? In polar form, 5, then your angle, negative 90 degree or negative j5, meaning that in rectangular form. So this comes to the end of this question. These are the solve related questions. Nothing is changing. The steps remain the same. All right.